Hi, Assalamualaikum. We are presenting our group project for vector calculus focusing on line integrals. This project is presented from group 2 and our group consists of 3 members. The first one is Muhammad AQIB bin MAAROF, Luqman Haqiem bin Muhammad SHAFIE and MOHAMAD ISMUL bin YUSOF. And again, my name is Luqman Haqiem bin Muhammad SHAFIE and my ID number is 2023389737. Begin with the introduction. So line integrals are the mathematical tools used to calculate the length or mass of a wire, the surface area of a sheet, or the electric potential of a charged wire. They are often referred to as curve integrals in calculus as they allow the computation of numbers along a curve or path. Line integrals can be used to estimate the work produced by a force when moving an item along a path. They can be used in both planes and space and can be used to integrate multivariables functions and vector fields across arbitrary curves. Vector line integrals are the more common type, calculating the integrals of scalar functions over a curve in a plane or in space. They are also useful in physics, where they can determine the work done on a particle as it exceeds a force field or the flow rate of a fluid across a curve. However, in some cases, line integrals may not be applicable when the trajectory is linear and the vector field such as constant force is uniform across the whole trajectory. Then the calculation becomes simpler and conventional integrals may be more appropriate. Now, we will break down the formulas and understand their applications. Let f be continuous in a region that has a smooth curve C. If 2 dimensions, C is defined as rt equals to xt plus yt, and if 3D, the rt has plus zt. Then we integrate fxy ds equals square root x prime t square, y prime t square, and z prime t square. If function xyz equals to 1, then the line integral represents the arc length of the curve C. Then integrate 1 ds equals to integrate upper and lower a and b, magnitude r prime t dt, and that is the length of curve C. For work done, the objects move from location A equals to RA to the point B equals to RB, and the work done along the curve C is given by the following line integral. W equals to integrate f dot t ds, and we can express to vector differential form, parametric vector evaluation, parametric scalar evaluation, and also scalar differential form. In this case study, we will explore 2 scenarios in which a force field acts on an object moving along a specific path, and we will calculate the work done using the line integrals. For the first case study, we analyze the work done by a force field along a cycloid path, and we are given the force field fxy equals to xi plus y plus 2j, and an object travels along a cycloid path defined by the parametric equations. For the second case study, we analyze work done by a force field along a straight line path, and the vector field given is integrate z squared dx plus x squared dy plus y squared dz, and the object moves along the line segment connecting the points 1, 0, 0 to the points 4, 1, 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin YUSOF, student ID 2023131357. I will start with the manual calculation for question 1. From the question 1, we will given the parametric equation and also the vector field. For the first step, we will let x equal to t minus sin t and y equal to 1 minus cos t. We also find the derivative of each term respect to dt. After that, we will integrate the dot product of f and dr from range 0 to 2 pi, and also we will substitute the value of x, y, dx, and also dy. After that, we will get the simplified version of the integral t minus t cos t plus 3 sin t dt with the range of 0 to 2 pi. For the term t cos t, we will have to do the integration by part. After that, we will get the final answer of 2 pi square as the work force. Next, for the question 2, we were given the line segment from coordinate 100 to 412. We will let P equal to the coordinate of 100 and Q as coordinate 412. From that, we will get the vector PQ as 312. From the vector PQ, we will substitute it into parametric equation. where vector PQ as parallel vector and also vector 100 as the position vector, and then we will expand it in order to get in the IJK form. Next, we will let x equal to 1 plus 3t, y equal to t, z equal to 2t. From that, we will differentiate each term respect to dt in order to get dx, dy, and also dz. From that, we will substitute the x value, y value, and also z value from the given integral from the question. After that, we will simplify the integral and we will get 23t square plus 6t plus 1 respect to dt from the range of 0 until 1. After that, we will solve the integral and we will get the final answer, which is 35/3. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AQIB bin MAAROF. My student ID is 2023168305. And let's dive straight into our first calculation. We begin by defining a 2D vector field F with components x and y plus 2. The maple represents this symbolically using basis vectors of e subscript y and e subscript x. Next, using Maple's plotting tools, we can visualize this field across a 20x20 grid. Notice how the arrows clearly show the linear x dependence and the y component that grows as we move vertically. Now, we'll analyze how this field interacts with a cycloid path. The curve RT equals t minus sine t in x and 1 minus cosine t in y. Taking its derivative gives us the necessary tangent vector components. To find the work done, we compute f.dr. After substituting our parametric equations into the field components, we get this expanded expression. Integrating from 0 to 2 pi yields our clean result of 2 pi squared, a satisfying exact value showing the total work done along this cycloid path. Now, let's examine a different scenario with field components 1 and x squared. The plot reveals how the y component changes drastically while x remains constant. We'll integrate along a simple straight path from 1 to 0 to 4 to 1. The parametric equations are straightforward. X increases linearly as 1 plus 3t while y equals to t. This combined visualization shows our red test path cutting through the vector field, and we can already anticipate interesting interactions from the varying field components. Breaking it down, dx over dt is 3 and dy over dt is 1, and after settling up and evaluating the integral from 0 to 1, Maple gives us the exact rational result of 35/3. And next is the references that we use, and that is all from us. Thank you.